Hello, I'm Ramon Miranda. Welcome to Chemistry in Action, a weekly program for teachers, students, and other viewers interested in the living world of chemistry. In the past 3 episodes, we gave you some insights into how chemistry is really part of our everyday lives. We've also begun to look into measurements. Today, we will be continuing that discussion on measurement. Join us for the next, I'm measuring again, 30 minutes in our episode, Measurement and Calculation. Temperature is an intensive property of matter. This means that temperature does not depend on the amount of substance. For instance, if I pour part of this sample of water into another container to come up with 2 smaller amounts of water, their temperatures would be the same. Temperature tells us how fast atoms and molecules move around. The higher the temperature, the faster the motion. The lower the temperature, the slower the motion. The thermometer is commonly used to measure temperature. In the laboratory, you may come across a mercury thermometer or an alcohol thermometer. Mercury and alcohol both expand with increasing temperatures, but alcohol expands more than mercury for each degree rise in temperature. Thus, it gives us more sensitive readings. Besides, it is less expensive, and if it breaks, the alcohol vapor is not toxic. But unlike this mercury thermometer, the alcohol thermometer is only good for measurement of lower temperatures. Thermometers are marked in degrees based on either one of 2 temperature scales. In the Celsius scale, the freezing point of water is 0 degrees. Its boiling point, 100 degrees. In the Fahrenheit scale, the freezing point of water is 32 degrees and its boiling point is 212 degrees. In many scientific calculations, the Kelvin or absolute scale is also used. In the Kelvin scale, 0 degree is the lowest possible temperature that can be reached. You will learn about the significance of absolute zero in a future episode. Earlier, we discussed how important it is to measure mass and volume. Mass and volume are both extensive properties of matter. That is, they depend on the amount of substance. This brings us to another property of matter that combines measurements of mass and volume. This is density. It tells us how much mass or matter there is for each unit of volume of the sample. Density can be expressed in grams per cubic centimeter or grams per milliliter. Unlike mass and volume, density is an intensive property. It does not change with the size of the sample. That is why density can be used to characterize a given substance. Let's look at samples of substances, each with their own density. Among them, air has the lowest density. Water is 1,000 times more dense than air. Rubber is a bit denser than water. And steel is more than 7 times as dense as water. For a pure substance, density does not change with the size of the sample. These 2 water samples have the same density, but density does change with temperature. That's because most substances expand slightly as their temperatures are raised. Density generally falls with rising temperatures. An exception is water between 0 degrees Celsius and 4 degrees Celsius. Densities for different materials are listed in handbooks and have been measured at 20 degrees Celsius. There are several ways to determine density. The method we choose depends on what kind of sample we have and how accurate we want to be. In finding out the density, we usually first determine the mass of our sample using a balance. We then find the volume of our sample using a method suited to our sample. Our demonstrator, Dr. Marcelita Magno, will show us how to determine density. We can directly measure mass and volume for liquid samples like water. Before starting, make sure that all the equipment is clean and dry. Turn on the top loading balance. Put the tare to 0. This balance has a sensitivity of 1/100th of a gram. In your own school, you may use a triple beam balance or a platform balance if this is what you have. First, determine the mass of the dry 10 milliliter graduated cylinder on a top loading balance. Pour about 10 milliliters of distilled water and reweigh the cylinder, this time with water in it. Remember to record the exact volume of water in the cylinder to the level of accuracy permitted by the graduations on the cylinder. The mass of the water is a difference between the mass of the cylinder with the water in it and the mass of the cylinder alone. Take the temperature of the water in the cylinder. Calculate the density of the sample. Compare it with the handbook density of water at that temperature. We can also get the density of solids with irregular shapes or appearances, like these pieces of copper. We do this by first measuring the volume of water the copper sample displaces in order to determine the volume of the sample. Into another clean and dry 10 milliliter cylinder, pour about 5 milliliters of water. Record the exact volume to the nearest 100th of a milliliter. Weigh several pieces of copper metal to the nearest 100th of a gram. Put them slowly into the graduated cylinder. Be sure that there are no air bubbles trapped between the metal pieces. Read the new level of the water. Calculate the density of the copper metal. If the calculated value is very far from the handbook value, it suggests that your copper sample is not pure. You can use this procedure for any other kind of solid, provided the solid does not dissolve in water or absorb water. After we absorb what we just discussed, let's have a few absorbing messages.